Okay, thanks. So yeah, I'm going to talk about master class on almond growing. And this is what I'm going to talk about. I talked about some of these things a little bit this morning, but I'll cover them in more detail. But I'm going to first talk about rootstocks, varieties, training systems, spur dynamics, photosynthetically active radiation interception and yield potential. Can everybody hear? Okay. Harvest, food safety, and irrigation. I'm going to start off talking about rootstocks. And there's a variety of rootstocks compared to pistachio. We have a lot more almond rootstocks, I think, because there's been an almond industry for a lot longer. A lot of these have come from private breeding programs and other sources, because we haven't had a rootstock breeding program for almonds until recently. We do now, or sort of a halfway program at least. So these are the rootstocks that are using Nemagard seedling, level seedling, Mariani 26-24 plum cuttings, peach almond hybrids, colonel or seedling, and then complex hybrids, Viking and Atlas, and recently Crimps 86 has become very popular, especially in the north part of the state because it's very resistant to blowing over. Might be useful here because I guess it's really windy here. So pretty much north of Davis in the Sacramento Valley, all the plantings have been on Crimps 86 for the last 3 or 4 years because we had some really bad wind events, including some tornadoes that came through and just wiped out whole orchards. So. You can get more detail if you go to this website. There's a more detailed presentation on rootstocks by Roger Duncan, who's a farm advisor in Stanislaus County. And these are some of the specific challenges for alkaline or salty soil or water. Peach almond hybrid is usually used, although it's not very good if it's a heavy soil or if they're ring nematodes. Those would be Hanson's, Bright's 5, Cornerstone, Titan, and BB 106, and then Viking, Empyrean 1, and Rootpack R. And then for Phytophthora, which I would say is really just water management problems. So if you have Phytophthora, you have to really look at your water management. That would be Mariana 26-24, Crimps 86, Mariana 40, Ishtara, and Citation. And then for poor drainage or heavy soil, we use Mariana, Crimps 86, Mariana 40, and Rootpack R. We're not sure about those last two. And then for verticillium problems, Atlas. So growers, if they have a specific problem, they'll choose one of these orchards based on that. And then anchorage and high wind, as I mentioned earlier, they use Crimps 86 now. They used to use Viking and Hanson. And then for bacterial canker and ring nematodes, they use Viking, Guardian, and Level. So that's a very brief summary of rootstocks, but there are a lot of rootstocks and they're really designed for specific problem areas. In general, almonds are self-incompatible. Varieties selected must be able to cross-pollinate, and newer varieties may be self-fertile, like Independence and Shasta are two self-fertile ones that have been introduced recently. And Winters, which is a university variety, is partially self-fertile. And then you really have to pay attention to pollen compatibility with almonds because you always need, unless you have a self-fertile one, you need at least two varieties or 3 or 4, as I mentioned, for the north part of the state. But not all varieties are compatible with other varieties. So in each row, the varieties in each row are not compatible with each other. So if you put, say, Aldrich and Price, Louise, do you have that point? If you put Aldrich and Price in an orchard, they will not pollinate each other, so it'll be as if there's no pollinator. So you have to be careful to not put varieties that are not compatible. Okay. Yeah, so if you put any two in the same row, they won't pollinate each other. These are the only self-fertile, or there's a few more now, but Independence is really the only self-fertile one that has any kind of a share of the market. It was really pushed really hard by the nursery. That's a variety that came from a particular nursery breeding program. And they sold it really well. They refused to put it in our trial, so there's been really no testing of it. So the growers are pretty big gamblers, and a lot of people planted it, and now it seems to be having a lot of problems. This is the approximate bloom periods, and those are the days before or after nonpareil. So the early mid here are 6 days to 2 days before nonpareil. And then these ones are 2 days before, 2 days after nonpareil, so nonpareil's in the middle here. And then late would be 2 days to 4 days after nonpareil. And late is 4 to 7, and then very late is more than 8. And you probably would be interested in varieties out here. None of these are very much used in our area because it tends to get too hot after this bloom period frequently, and so you frequently have problems with heat damaging blooms if you put these later varieties in there. So most of our varieties are in this range, some in these two groups. But these would be blooming in nonpareil blooming about mid-February for us. So I don't think most of our varieties would be very compatible here because as we had said today, you really need later varieties. And then one other big problem we had is bud fail, non-infectious bud failure. This is a genetic disorder, and it starts off with one scaffold just becoming bare like this. It'll have these poodle tails at the end, just some leaves at the end, and then the way you diagnose this is the next year another scaffold will go, and pretty soon the whole tree will be enveloped. If this happens after about the 5 years, it doesn't really hurt too much. It looks bad. Growers don't like orchards to look bad. But if it happens in the 2nd or 3rd year, you pretty much have to pull these trees out. And the most common variety that's had this problem is Carmel. It's a really desirable variety for other reasons, but it has tremendous problems with bud failure. Bud failure is somewhat related to water stress and temperature as well. It confounds things. These other varieties have also shown it, but not as severely. And then in terms of harvest timing, I think this is also important for you because you want to have probably early stuff to avoid. Well, you have kind of rains all through the season, I guess. The harvest timing here is for the area around Fresno, so this would vary depending on where you are. It'd be different for you guys for sure. But 1 to 2 weeks after nonpareil are these varieties, and then 2 to 3 weeks, 3 to 4, 4 to 5, and 5 or more. Most of these varieties aren't planted because that much later after nonpareil, this would be sometime in October. We're usually getting a lot of rain because we dry the nuts on the orchard floor. This is really problematic. And we frequently get these food safety problems I'll talk about a little bit about later if you have these really late varieties because of wet conditions. This is the percentages of acreage planted by varieties starting in 1990, then 2000, 2010, and 2015 is the yellow. So you can see nonpareil still really dominates, followed by Carmel. And these arrows just indicate that Carmel's been going down over these years. Butte's been going down. Monterey's been going up. Padre's going down. Price. And then the ones that are really coming up are these. This is Independence is over here. You can see it really took a big jump. So a lot of people planted Independence in the last few years because they can plant a whole orchard of Independence, not have to harvest on 2 different dates. With most other combinations, you're having 2 different harvest operations. So you end up driving through the orchard twice as much to harvest because you have to shake and you sweep into every row. I'll show some pictures of harvest later. So this is really beneficial in terms of operations. Also in terms of sprays, because sometimes you have to spray one variety and not the other. So it's really nice if you can have one variety that's self-compatible, but we don't really have an ideal one yet, I would say. And then this is the crop payouts by variety. This data came from Blue Diamond growers, and you can see for the last, how many years is this? 2010. Sorry, it's going up, but you can see the nonpareil's always paid the best. Independence is not on here, but it was paying the same as nonpareil prices, but now they've really decreased the payments on that. The processors aren't real happy with it. So, how was training slides? Sorry, that slide was supposed to be first. So I'm going to talk a little bit about training systems, and that slide's supposed to be later, but that's all right. Traditionally, trees were headed at about 1 meter, and this creates a lot of problems because all these branches end up coming up. Because we mechanical shake, we have to have space here to grab the trunk. And so by the time you leave enough space for the shaker to grab, all these branches end up very close together. And by the time you get to about 4 or 5 years, let me go back to that picture, this happens. We have lots of orchards that have tremendous problems with splitting because all these branches come out at the same place. As the tree ages, sometimes they collect water and leaves in here and it rots and these things will just split out. So it's much better if you can get the scaffolds more widely spaced. The taller you leave it, the better, basically, from our experience. So if you have it widely spaced, these scaffolds are a really nice pattern. They're not, even when they grow big, you can imagine in 10 years, this scaffold's going to be this big, this one's going to be this big, and they're not going to be competing with each other for space. So we did this trial on campus a few years ago. This is a third leaf, I think, picture. And we either had it at 90 centimeters, 150 centimeters, 110. And this one got cut off, I forgot.
130?
Oh, that's, yeah, 130, I think.
It's written in the end, same, so it's supposed to be 170.
Yeah. Anyway, so we had it at all different heights, and basically after this orchard's actually just abandoned this year. This is on campus, and it's planted really too close together for mechanical harvesting, and things are very difficult in here. And we have a tremendous, I think the same problem someone was mentioning earlier. Oh, I was in a crow problem. Crows and rabbits and squirrels eat all of the nuts, so we essentially get no nuts off of this orchard. So we're only looking at the shape of the trees, but we can't really we got yield data the first couple of years and then we gave up. But basically what we found out is that the taller you left it, the better the tree structure was in general. So there was no advantage to cutting them short. And we did this trial at a different research station where we tried to generate central leader trees on almond, because the almond board, the person from Agro-Minora was talking about dust. Dust is the biggest problem for the industry now, and they really want to go to catch frame harvesting for almonds, but our current system of growing a tree really doesn't work very well. They're too big, too wide, and we don't have a big enough catch frame. So they wanted to generate a central leader tree that would be more compact. And so we tried this trial and we didn't have any luck. It's almost impossible to generate a central leader tree with almond. They just want to get the normal almond shape. So these side branches will just grow up and you won't end up with a central leader. This orchard was planted at the trees were about 2 meters tall, and they were just planted and just left, and that worked really well, other than the fact that we didn't keep a central leader over time. This is what the trees look like this year. Oh, what happened to the, oh, this is one that's got the time. So this is switching to pruning as the trees get older. Sorry, this has got this time thing that I forgot. Just want to get them all on there. Okay, so I just went through all the almond trials. So I started this job in 2000, and a lot of this work was already ongoing when I started, so I wasn't involved. I was involved in about half of these trials. But over 13 years, basically on all these varieties, we had cumulative yield data for this many years, conventional and annual pruned trees. This is the cumulative yield over that period, and then this is the unpruned trees. And in almost every case, the less you prune, the higher your yield was over 13, 8, and 13 years in these different trials. This is the only exception where Aldrich and Carmel did slightly better in but not significantly better in this one trial. So basically, the less you prune, the higher you yield, higher your yields. There's generally not a benefit to pruning almonds. A lot of growers like to get a certain structure of branches, so they prune in the first and maybe second season, dormant seasons, and after that, most of our growers don't do any pruning after that unless there's a branch that's in the way of a shaker or tractor axis. They remove limbs that are too low for the shaker, and also limbs that cross over through the tree they don't like, so they'll take those out. And every pruning cut you make decreases yield, and you never make that up, so I say just let the trees grow. This is also true of walnuts. Walnuts, we found out there's never a benefit to making a pruning cut. Next, I'm going to switch to talking a little bit about spurs. Almonds bear on these spurs that can live up to 15 years or more. The common wisdom was they lived for 5 to 7 years, but that was because the trials that were done the spurs got shaded out by the outer canopy. So if they get shaded, they will die, but a spur in an outer canopy position will live for a very long time. So we set up this trial. I actually was given this trial when I started by some other people in our department. So this will be a great trial for you to learn about almonds. So we started this trial in 2000, I think, or something like that, 2001. And this is a spur. So each individual spur acts pretty much independently. So in a mature almond orchard, the majority of crop is born on spurs. They're short proleptic shoots that can live for many years and can produce from 0 to 4 or more fruits. And this is what we did. We tagged 2,000, 2,400 spurs on trees all the way through the canopy from the very beginning. I think this was a 6-year-old orchard when we started. So in all 4 quadrants of the tree, we tagged either 12 or 13 trees. We just wanted to make it out to 50 in the total. And then we followed all those spurs for 7 or so years, 6 years. And this is what the spurs look like. And what we found was, so we went through and we got an adjacent spur and measured leaf area every year because we could always find a spur that looked just like the one that we had. So we compared leaf length. We were able to take a spur and measure the leaf area back in the lab. This is what we did. We did an image of this. We used Photoshop to measure the area of these leaves. And this is what we found is that if a spur bears 1 year, so this is the spur with no fruits in the previous year up here, it's the probability that the spur survival was very high. So if it didn't bear, it almost always lived. If it bore fruit and it had a small leaf area, it frequently died. And what we found is that in this trial, only about 14% of spurs actually bore fruit in any 1 year. 35% flowered, but only 14% bore fruit. So what we found is that individual spurs alternate bear. This is a paper if you want to read about this. But what we found is that the numbers of flowers was more important than the relative number of flowers, but also that any individual spur that bore 1 year, its chance of bearing fruit the next year was almost 0. So each individual spur totally alternate bears. It has fruit 1 year, the next year it's vegetated. The year it has fruit, it has very small leaves. So this is the leaf area per spur. If it had no fruit, it was very high. If it had 1 fruit, it was less. If it had 2 fruit, it was less, 3 or 4. And then this is the number of leaves per spur, which basically followed the same pattern. So each individual spur is preparing to bear the next year. So it has a lot of leaf area this year, the next year it bears. So we went back to that trial. We drove by one day and we realized the grower had taken out this trial. We had abandoned it quite a few years before that. And so after 16 years, we went there and we still found those tagged spurs. If they were in an outer light position, they were still alive at the time they removed the orchard. So the individual spurs can live for a long time if they're not being shaded out by increasing vegetative growth. So the summary of all that is, although individual spurs are strongly alternate bearing, almond trees in general are not, since only a limited percentage of spurs bear in any given year. So pistachios, Louise will probably talk about this, but they might bear 80% 1 year and 20% the next year. Almonds would be more like 70% and 80. They're much closer from year to year. You can see there's somewhat, this is the statewide yield, and it does vary somewhat from year to year. And then this is the statewide total yield in terms of million metric tons per hectare. And this is what our data with our light bar has shown, that we can actually produce much higher than, so the average orchard in the state is only producing a little bit more than half of its potential. A lot of this is because a lot of these are younger orchards that aren't coming into full bearing yet. They haven't fully developed their canopy, but we have a long ways to go. But of course, we always have orchards in here that are aging. As orchards age, we find, I don't think I have it in here, but we find that orchards peak in yield at about 12 years. If it's managed perfectly, somewhere between 11 and 13 years, it will start declining. Even if you're not losing any trees, the yield will go down. I've been told by other colleagues that that's because you don't prune enough, but if you prune, the problem's actually worse. That does not solve the problem. We do see occasional orchards that are producing at 30 years of age, but it's very unusual. And the only one that I've had any experience with is one that was flood irrigated, a very old traditional orchard that was 30 some years old. It was flood irrigated and it wasn't missing 1 tree, and it was still producing very good yields after 30 years. But generally, all of our trials with new planted, more densely planted trials have decreased after 11 or so years. So this is an orchard that had 4.5 metric tons per hectare. You can see how much crop there is here after we shook the trees. You can see also that one of the other things about the spurs is, remember, the spurs that bear have very small leaf area. But they also often drop those leaves late in the season, so you can see how barren these trees are. This orchard probably had a very high percentage of the spurs bearing, and the tree and the leaves. You can see how many leaves are on the ground. A lot of these yellow leaves are the ones that were associated with the spurs that were bearing, and they fell off when we should have. So we're trying to figure out how do we get to that point? And this is a really high density orchard, probably too crowded, but basically everyone kind of knows that you have to have a big tree to produce big yields. So that's how we quantified that. I talked about this a little bit this morning with this light bar. So we set up set it up outside of the orchard. Well, I also mentioned that we have a GoPro camera on here that takes pictures of the orchard floor. So we've also calibrated the images of the shadows, so we can actually calculate the light interception pretty well. We have to adjust for almonds and walnuts differently because sunlight comes through the canopy. So with that, we take a picture of the orchard floor, and then we straighten out this picture, count the pixels that are in the sun and the shade, and we can calculate the percent interception that way. We have an iPhone app that does this, but it's not working at the moment because Apple's the language it was written is no longer supported by Apple. So we're going to rewrite that. This is what we do. We set up this weather station outside to make sure that we're not losing any, or not having any clouds passing over. We drive the light bar through the orchard at about 10 kilometers per hour. And then afterwards we go through and we pick up those same nuts. This is the view of the GPS path on Google Earth that device creates when we finish. So it's really nice. You can see exactly where you drove. And then we have those same, I didn't talk about this morning. We have those same GPS unit on the harvester, so we can then go in and harvest those same. It's a little bit complicated because with almonds, because we have two different varieties, we have to keep track of that left side of the light bar as we turn. So we have to add those two halves together each time. With walnuts, it's much easier because we actually do the whole middle of the row. So almonds are a little confusing. And this is the total data that we have. Now you can see we have a ton of points. And this is the average for all of the state, or all of this data. It's about 0.045 metric tons per hectare for each 1%, or 4.5 if you could intercept 100, but more like 3.6 or something. In our best orchards, this is our best orchards that have maintained this yield over time, so they might be alternating around this line like this. They can produce about 4.5 to 5 metric tons at 80% light interception. So this is our goal, is to get in this range. Now if you see all these points down in this range that are off this line significantly, this in particular, a lot of these came from one orchard that we had a trial in, and the grower extremely over irrigated and made the whole orchard almost vegetated the next year. So he kept it way too wet for a whole year. The next year the crop was down here. The previous year the crop was up here. So this one really did alternate bear. So you can create alternate bearing situations in almonds, but not if you're managing water properly. And this just shows some orchards at different levels of interception. This is 39%. That's 2.2 metric tons per hectare potential. 50%, 2.8, 80%, 4.5, 90%, 5.0. And then, as I mentioned earlier, we don't like to get to this level because we have tremendous food safety risk when we do this, because these orchards are very difficult to dry the nuts on the orchard floor. So we don't like to do 5 metric tons per hectare. But as I mentioned this morning, these data all come from southern San Joaquin Valley, where it's very dry, lower rainfall, all the water is applied by irrigation. In the north part of the state, we generally don't get this high of yields, and around Davis, we get about half this yield because of the cold effects of the delta influence. And this just shows what we do with this data. So we can go in, this is a trial, but we can take data from one of our trials, but we can put that data on here and we can see how an orchard is doing relative to the average. So we can do this in a grower's orchard. He should say, well, you're not getting great yields, and we say, yeah, you are, but you should be up here because you're at 80% interception. You could be up to this line or above it. So it's a good way to diagnose your practices. You can see if you're above or below the state average. Growers aren't really able to do that without having a method like this. This is an orchard where we had a trial and it did alternate bear fairly severely. This was a very high yielding trial that we have. So some orchards can alternate bearing. We're not really sure why this one was alternate bearing quite so much. Probably partly because of water problems. It had an infiltration problem, so water perched on the surface frequently. It probably was related to that. Now we also went in and compared an orchard. This is that same orchard I showed on the previous page. 298 trees per hectare, 5.5 by 6.1 meter spacing, so it's fairly high density, but not real high density. We compared that to one of these super high density orchards with 2,020 trees per hectare at 1.5 by 3.3 meter spacing. And this is the light interception falling above the orchard, and then this is the interception. The PAR interception for that high density orchard is here, so you can see what happens. This is over the course of the day. So you can see what happens in the middle of the day. A lot of light hits the orchard floor and the interception goes way down, whereas this orchard's intercepting fairly similar amounts of light through the whole day. And this is the integration of the PAR and this and this integrated. So this is the amount of energy that's absorbed by the leaves. So you can see the conventional planting has much higher interception than this high density plant. This just shows pictures through the day of what happens with the sun. That line shows where we are. So this is at, I can't see the axis very well, 9 o'clock, I think. And as the day goes on, you can see what happens in this high density orchard there. Now all this light is falling on the orchard floor. None of it's being used for producing crop through this middle of the day, so that's why you get this big dip here. And the common wisdom is, you have this fruiting wall and you're gonna produce, this is well lit, it's gonna produce more fruit. We haven't found that to be the case at all. We still find that same relationship between light interception and yield as in a normal orchard. And in fact, this orchard had tremendous disease problems because in order to fit the grape harvester over these trees, he had to mechanically hedge it about 2 times per year. And all those cuts got infected with different organisms and had tremendous disease problems, and he took this out after 4 years. This was just a small trial. I think there's a little bit of the yield data here. So this is the potential yield for this high density one. Or sorry, the normal density at 40. Now this is the high density, 44% interception. This was in the 3rd or 4th leaf, I think. 3.8 metric tons per hectare potential yield, but it actually only had 1.3 because of all the hedging, the diseases, and all the problems that have been caused. This is the more conventional, still high density, but not extremely high density. 83% interception, 5.8 metric tons per hectare potential. It's probably a little less than that, but the actual yield was 3.6. So you can see we got much higher yield. We also did the same thing in high density olive orchards and found the same relationship. And part of the problem is in California, these orchards just grow so rapidly from the winter rainfall. Even though this site doesn't have a lot of rainfall, you still get enough growth in the spring that you're always having to cut it. The only place we saw that it worked pretty well was where there was a big gravel streak through the middle of the orchard where the trees didn't grow. So you might be able to prevent some of those problems with water, but it's kind of difficult. But basically the main problem is you have to devote all this space to dry row. So we have to be able to drive a tractor through here to pick up the nuts, to mow, to sweep, to harvest and sweep and all that. Or not to harvest, this is an over-row harvest. So we think we can do somewhat better. We have a few of these Tenias harvesters from Spain now in California. They built a bigger version for us for our trees because the trees in Spain are smaller. And we have had some luck with this, or we think we can create an orchard that will work, produce decent yields, probably 3/4 our maximum yield maybe with this system. If we get the spacing right, because we can probably move the trees closer together because we don't, right now they're still picking up they're still using a tractor to get the nuts. Because these reservoirs on this machine were designed in Spain, they're not big enough for our orchards, and we can't make it all the way through the orchard to the end to dump them. So this machine actually takes the hulls off of the tree as in the orchard if you wanted to. What we're doing right now with it is just shaking the nuts off and dumping them back in the middle of the row, mainly to avoid the dust of sweeping, because when you shake the nuts on the orchard floor and sweep them, that's where you generate the most dust. That's a huge issue for the industry. Closer. Okay, thank you. lower. So I'm going to talk a little bit about the potential impacts of orchard management on food safety risk. This has been a big problem in almonds. We've had a number of salmonella outbreaks in almonds that were related to wet falls. And part of the problem is almonds are stockpiled in California because the haulers can't keep up with the volumes, and so they get stockpiled like this, and lots of things can grow in these stockpiles. They're just put outside, and then you can get condensation on here depending on the weather, and the water can wet the nuts and create mold. And the problems we had were actually with the orchard floor. So this is an outbreak I started in 2000, and I was involved in this case. It was an outbreak that was happened in Ontario, Canada, and it was traced eventually to one individual grower in the U.S. The Canadian health inspectors were very astute, and they noticed that all of these cases were around one particular bulk food distributor, natural food distributor, who was selling the bulk barrels of nuts. And all those nuts turned out to have the exact same strain of salmonella. All of the cases came from there. They went and sampled those nuts, and they traced them to one individual grower because they had a trace back for where those nuts came from. And that orchard is still quarantined. This was, 19 years ago? You still can't sell the nuts from that orchard raw. They have to be blanched or something. And this is a 3,000-acre orchard, so it's a huge orchard. So it's really a problem for the grower. He says that basically eliminates his, because when he runs these nuts through his huller, he has to clean the whole huller and have it inspected by the state after he finishes to make sure there's no salmonella on the machinery. So it's very, very costly for him. And then we've had a number of other outbreaks. One in 2003, 47 cases. We seem to always aim these at Canada for some reason. And then the handler was, so one of the other things about this case was that there was one case that was not related to this grower, but it turned out that it was a friend of his, and he was sharing harvesting equipment with him, so he actually got a salmonella outbreak from sharing the equipment. And we spent a lot of time. We had a big federal grant to look at this. We brought in veterinarians and from the Midwest, Minnesota, who work with cows, and they were amazed when they saw that we dropped these nuts on the orchard floor, sweep them, and then eat them raw. They said, "You're crazy. You shouldn't be doing that." Since then, all nuts that are sold in the U.S. have to be pasteurized, either by heat or by chemical treatments. They're not required to be pasteurized for export. I'm not exactly sure why that is, but the only reason that only ones that are not pasteurized are ones where the company, like if Mars Candy buys them, they can show that in their processing process they go through a kill step that's equal to the pasteurization, so roasting or something like that. So, what does that say? It's the right word. I don't know who translated that. I hope they didn't translate this. Okay, so they can either be oil roasted at minimum of 260 degrees Fahrenheit, 127 degrees centigrade for 2 minutes, water blanching and remove the outer skin for 2 minutes, or propylene oxide. This is probably the most common method, I think. And then 2 different steam treatments. Now, a lot of grocery stores sell these as, I think they call them almost raw because they don't really taste raw. They have a little bit of a roasted taste. Actually, they taste kind of good sometimes. So that's been a big hassle for the industry. And this is one of the things growers say, well, now that they're pasteurized, I don't need to worry about food safety, so I can just grow the orchard to 90% cover and produce 5.5 metric tons per hectare. And that's not true though, because these things were set up for the current levels of salmonella. So they looked back at the levels of salmonella over the last 10 years, and they decided that they needed a log 4 reduction. So if you actually create higher levels of food safety related organisms, this system won't work, so you'd have to pasteurize to even higher temperatures. And as I mentioned earlier, only nuts sold in North America are required to be pasteurized. You can sell them, individual growers can sell them at farmers markets and things, not pasteurized, but anyone that go into the main system have to be pasteurized. Sampling, that's from the orchard floor. Oh yeah, we did this trial to see what happens. So what happens, growers shake, and some of them leave the nuts right here under the tree to dry, and other growers sweep them and put them out in the middle of the row, windrow them. Some growers do a better job of spreading them wide, but this grower just put them as if he was gonna harvest them. And what we did is we just measured the moisture content in these nuts as we went away from the tree in both directions, and then we measured the moisture content of the nuts in this windrow. And what we found was at the end of the drying period, the nuts that were under the tree had 2% higher moisture than the ones out here. And then the nuts that were in this windrow had about 2% higher moisture in the bottom of the windrow than in the top. So there's a lot. So this is putting a lot of variability in the whole system. So it's really better. There are a lot of growers who have new conditioning machines that pick the fact that Tanias harvester does a better job of spreading these, so it actually spreads them into an even layer. But food safety is a big concern. And the other problem is, if you have an orchard that has a lot of variability in light interception, there's tremendous differences in the drying of the nuts in the areas where the trees are small versus where they're big, so depending on the light that reaches the orchard floor. So normally the nuts are left to dry for about 7 to 10 days, but if it rains during that period, you start the whole process over. The year that original food outbreak occurred in California, there were 3 rain events in that orchard where they started picking them up at rain, they spread them back out to dry, they started picking up again at rain, so they went through 3 cycles of wetting and drying, and that's what probably created that problem. I started mentioning that we brought in experts from Wisconsin. They never figured out where this salmonella came from. The orchard where that outbreak occurred was right next to hills that were just grazing land, and so it's possible that it was animals that came through there. They actually caught a bunch of foxes and squirrels and things and checked them. And the only positive they got was from one crow, but they found out that the grower had smashed the crow on the ground with his foot. And so I don't know if the contamination came from that act or from the actual crows. So it was never determined where the contamination came from. And what happened is they started hedging that orchard. In fact, we did a hedging trial in there where they hedged to either 2, 4, or 6 feet. So they cut the middle of the row up. And that's where we originally got the data on yield, light interception versus yield, because that exactly fit our pattern that we found later. And it did help. So they were doing drag swabs in the orchard and just dragging along the surface with little milk impregnated pieces of cotton, or little, I guess they're cotton swabs. And after they hedged it, they did not test positive for salmonella. But the first day they started the harvest operation, all this dust, the salmonella was deposited back over the whole orchard, so it's just under the surface, and salmonella can live forever in those conditions. The other thing I didn't mention is those 90% canopy covered orchards, which this one was. The temperature of the surface of the soil is almost ideal for salmonella across the whole orchard, whereas in an orchard that has lower light interception, that problem only occurs under a little bit of the trees. So there's a real trade-off. We also did some of these measurements in Oregon hazelnuts. I guess there's no hazelnut people in here, probably they're all next door. But we found that in hazelnuts it was the opposite effect, because they're so shaded and it's so much cooler in Oregon. That might be true here too, that it was actually the higher interception had less potential for food safety outbreaks. Because Oregon's also had problems with salmonella in the hazelnuts as well. So this is just pictures of the shaking operation, sweeping and pickup. And this is the dustiest part of the operation. Anybody who's driven by an almond orchard when they're sweeping, especially in the southern San Joaquin Valley where it's really dry, this creates tremendous dust clouds that just go way up in the air. It's really a food air quality concern, and growers are getting dinged for this. So they're really trying to figure out how to avoid that. And they're picked up with mechanical harvesters and brought to a hauler, dumped into these trailers and hauled. And then briefly talk about irrigation. This is what I spent probably the first 5 years of my career doing, was related to irrigation scheduling and almond water relations. And there's either calendar method, plant water status, soil moisture measurements, or evapotranspiration. We don't recommend this at all, but still probably, I would say a majority of growers still just irrigate every 10 days, every 3 days, depending on the irrigation system and soil type. That really doesn't work very well. We really like a combination of these two methods, maybe all three of these methods. And this is what we use as a plant pressure chamber to measure the water potential of the tree. And the reason this works is because water is pulled from the surface of the leaf. So the air is about at minus 9.5 megapascals of tension. Air near the leaf is minus 7. The air in the leaf is minus 1.2. So there's this gradient of water potential up the tree. If that wasn't the case, water wouldn't move up the tree. So the water moves up the tree by evaporating at the leaf surface and pulling the water up from the roots. And so what we do is we bag the leaf right down here low on the tree. I think your battery just died. I got the other one. So right in here. Oh, this one's no good.
Try the pointer for the advancer.
Where's it? Okay. That one works. Okay, yeah, so we bag a leaf. The lowest leaf on the trunk, basically, you have to have a fully formed leaf, so it has to be mature. And then we put it in a Mylar bag at least 15 minutes before we're going to do the measurement, and then we come back and we take that leaf. So this is what you're measuring. If you have watermark sensors, when you're measuring 30 centibars, that's what this is. This would be 30 centibars or 0.03 megapascals when that gradient goes up the tree. So we found that this is by far the best method. It's basically like measuring the blood pressure of a person, because it integrates across the whole soil moisture. It's what how hard of a time the tree is having to pull the moisture. And these are some of the different types of pressure chambers. This one's from soil moisture. These are now about $8,000, and then there's this bicycle pump-up version, and these are about $1,800, I think now. These don't work real well on almond because it takes about a half a bar per pump, and almonds can get to minus 20 bars, minus 2 megapascals. And so it's 40 pumps to get to that. So you're doing it at the hottest. We sample between 1 and 3 in the afternoon, so it's 40 degrees C at that time, and you're out here pumping 40 times for each leaf. So I bought one. The person who invented these is in our department, and he gets a royalty from these, so he talked me into buying 2 of these when I started. I took it out for one day with a farm advisor who's known as being grumpy, and he said, never bring that thing back to my county again. So it's used to measure the tension in a leaf. The midday stem water potential is normally expressed as a negative value, so we always put a minus sign before. Water potential is done on a bagged leaf at midday are known as midday stem water potential. And this is what I spent many years doing. So we have really good data on almonds and walnuts. You can find it probably on the Fruit and Nut Center website. I have some references at the end that shows what a tree should be right after you irrigate. So you bag a lowest shaded leaf you can find at midday, and that allows we call this the trunk water potential because it allows the water potential to equilibrate with the water potential in the trunk. There are quite a few companies selling sensors now that you install in the trunk and give you this data, but we've never found that any of them work very reliably. They're actually measuring the tension inside the tree trunk. And this is what you do, then you pressurize it either by the hand pump or we use a nitrogen cylinder, and then you just watch. You don't want the water gushing out like this, but you just watch it until this is a walnut leaf. They're very easy because they have very distinct, this is the xylem, this horseshoe. You just wait until that darkens, and then you take a reading right at that point. You don't want it to be bubbling, you just want to get it just to the point where you see this light color darken. Almonds aren't quite as easy, they're a little bit harder to see this, but they're still relatively easy. Pistachios are a pain in the neck because they exude all this latex that confuses everything. And this is what happens over the course of a day. So if you have a fully watered tree, it might start at 0.4 or so megapascals. It decreases to around 8 or 9 to 0.8 or 0.8. We usually use bars, that's why I keep getting confused. I convert these units to megapascals. And so this is why we sample at midday, because there's kind of a flattening, although it doesn't really totally flatten, but we take the readings right at this period. And then if you have a moderately stressed tree, it does this down to about minus 1.4 megapascals. And then that's a mild stress. Moderate stress would be about minus 1.9 in almond, and then severe stress, you don't ever want to get here down to minus 2.4 megapascals. Now, one of the other things is that we've had some real problems with when you have different heights, when you have pollinizers that are taller than the main variety, or whatever, one taller variety, one shorter. At like 10 o'clock in the morning and 3 o'clock in the afternoon, they intercept much more light than this tree. And if you measure water potential at this time, this tree will be totally recovered and this one will be really stressed. So it's kind of tricky. This tree is actually going to use more water because it's intercepting light for a bigger part of the day. So when you have multiple varieties, it can be it's easy to overwater these shorter varieties. And also in terms of yield, about 20% of the yield can be shifted from the shorter variety to the taller variety just because they're intercepting more light over the course of the day. And the next thing we worked on is where you should measure. And we do is usually a transect that the orchard's very uniform. We first go in and we sample probably 10 or 20 leaves all the way across. Or if there's some gradient, we look at the Google Earth image of the orchard and decide where to sample. So we get a representative sample of the shade, how big the trees are. Because generally, one of the really useful things about a pressure chamber is if those small trees are less stressed than the big trees, then you know it's because they're too wet, and vice versa. So it's a very good diagnostic tool, especially if you measure just before and just after you irrigate. And this is the difference. Walnuts and almonds are very different. Walnuts operate at about half the water potential of almonds. That's why the pump-up pressure chambers work a lot better on walnuts, because you only have to do half as many pumps. And this is what happens over the season on average in California. This is mainly because of temperature and BPD, and they start cutting back for harvest at this period too, so you tend to get more stress. And one of the things that we've did a lot of work on early is looking at how that water potential affects the canopy development. So an orchard that averages 0.8 megapascals, it's not too wet, but towards the good soil moisture range, or the good soil moisture range, will grow much more rapidly. So over 8 years, it might be at 3.5 or 4 metric ton per hectare yield potential. If it's at 0.4 megapascals less, it will grow more slowly. And again, minus 1.6 megapascals. And if it's too wet, and this is our biggest problem in almonds and walnuts, maybe pistachios too, I haven't worked with pistachios enough to know this, is being too wet. If trees aren't growing, usually they're too wet. Almost never do we see trees not growing because they're too dry. You get approximately a 5% loss in the rate of canopy development for every 0.1 megapascal of seasonal average water potential deficit. I think these would be extremely useful here, because if you get summer rainfall, it's going to be really tricky to manage the water, I think, because if you're using drip irrigation and you have a small wetted area and then you get a big rain event, all of a sudden those roots are already wet and you can just really hurt the trees quickly. So it's a little bit tricky to, I think it might be better to use micro sprinklers, but I've heard it's so windy here that that's really problematic. So. And one of the other things to use this pressure chamber, that data to interpret it, you have to account for the temperature and humidity. So this is the temperature in degrees C, and this green range is the range that we see in California. So on a given day, if it's 20, we tend to have very low humidity in California. So if it's 20%, a normal day in the Central Valley will be about 25% relative humidity and 35 to 40 degrees C. So we often run in this range. But in a very hot day, the baseline, which is what a fully watered tree would do, would be minus 1.1 megapascals. If it's a really cool day with higher humidity, it will be 0.6. So you can't just take this reading and interpret it. You have to account for it with this table. There's a different table. We have tables for almonds and walnuts on the Fruit and Nut Center website as well. I think there's a little handout on here. Yeah. This is a little handout I made. I have one of these for almonds and walnuts that describes how you use the pressure chamber and has these tables in there. This just shows an orchard that's running at minus 8 megapascals average over the season versus 1.2 megapascals versus 1.6. And this bottom line shows you how much return you lose because of the slower rate of canopy. So this is the tree size down here. So in this orchard, you lose that amount of yield over 8 years, and that amount of profit. this is in euros. You can see the trees getting bigger. And then this is the total per hectare loss down here. So you can see if you an orchard at minus, let me see if we can. So after 8 years, you can lose up to, what is that? 31,000 euros per hectare if you're running at a lower water potential. So it's really, and you would not see the difference between these probably and the trees. It'd be hard to see. It would maybe not be growing as long through the season. This one you would probably see, but it's very, that's why a pressure. So pressure chamber is essential to get your returns back as quickly as possible. I think this, Janine Hazy, who's a farm advisor, and I went on a walnut farm call one day, and the grower, actually, I said nobody under irrigates the orchard. What happens is if you over irrigate early, late in the season, the trees tend to be very, very prone to getting stressed. This was in August, and the trees had been over irrigated, but now they were, because the root zone's very shallow, you're pushing the water through the root zone, and so the trees can get extremely stressed later in the season if they're too wet early in the season. So just going in and measuring late in the season is kind of problematic, because you might think, oh, I'm not putting on enough water, so the next year put on even more water. So you really have to start this measurement in the springtime. So this is the difference between 80% development versus 48% over that period of time. So you can see this is a huge difference. So we went on this farm call. The grower had, all of his walnuts were black from stress from lack of water. And we pressure bombed the trees, and they were almost dead. And he said, well, I can't afford to buy one of those. And his son said, hey, we lost more than the price of one of those on 1 acre. So, you know, it's a really good tool, I think, to have. I think I already talked about all that. So one of the problems we have is, you know, if you looked at those tables earlier, 1,400 millimeters is very difficult to apply on most of our soils. If you try to apply that amount of water, you almost always have problems in some parts of the orchard because there's soil variability. So it's a little bit tricky. And this is what happens if you're over irrigating an orchard like this. You can see these sides, but these are different growers. This grower is doing a good job. Very uniform, probably under irrigating a little bit. This grower is probably over irrigating. When you over irrigate, the small trees get wetter, and pretty soon you start losing trees, so you start seeing all these holes. So whenever you see an orchard that looks like this, I noticed some of the pictures this morning look like this that somebody showed. This is a sign that the orchard's been over irrigated. And as I mentioned earlier, this is our biggest problem. When I started this job, because I'm a statewide specialist, I work with all the farm advisors in the state. They call me when they have a problem. And about 90% of the problems I went out for the first 3 or 4 years were over irrigation related problems. This is a huge problem for us. Even during the drought, maybe even more so during the drought. So this is that table I showed earlier. This is the light interception. This is the amount of water required to support that amount of canopy. This would be in Bakersfield. Your numbers would be probably significantly less than this because it's cooler. In Davis, we would probably have about maybe 90% of this level required. But it's very difficult to put on this amount of water in most orchards without hurting trees. So in order to get to 80% interception, which is our goal, we need about 1,400 millimeters of rainfall or combined rainfall and irrigation. That's a wet condition like yours, or it rains during the summer. You don't need to, we can get about over half of this requirement from stored moisture in the northern part of the state. So that's why the pressure chambers really helpful. The most useful, the most beneficial use of the pressure chamber, from my experience, is deciding when to start irrigating in the springtime. Because you can keep measuring the leaves until the tree tells you it needs water. Most growers start as soon as they see water in the irrigation canals or they see their neighbor irrigate. So it's really helpful to have a pressure chamber to start in the spring. This is, I think I already showed this. This is just different levels of interception and the yield potential. So this is really what we're shooting for, is something that looks about like this is a mechanically hedged orchard that's hedged in order to dry the nuts. And hedging works okay on almonds. It doesn't really work on walnuts because you just get a huge growth response to the hedge and generate all kinds of vegetative growth. You don't get as much of that response in almonds. And this is some dryland orchards in Spain, similar to what someone showed earlier. These are just dryland, and this is about the amount of canopy that you could expect based on the rainfall. So they're almost using all the rainfall. When the trees are spaced this far apart, the trees can almost not be, I mean, they're not irrigated at all. Problem is the rainfall is not consistent from year to year. So if you get a few wet years in a row, you can grow a bigger canopy that you can support. But these are usually the ranges that you see in Spain for dryland trees, somewhere between 20 and 30, so you can produce about 0.6 to 1.5 metric tons per hectare with dryland. We still have a few dryland almond orchards in California, but very few, but they pretty much fall in the same range as our table is. But you have to plant the trees very far apart. If you put them too close together, you're just gonna kill them. And it's hard to know how far apart to plant them. This is one of the other issues is we have on these young trees. If you're irrigating this as a micro sprinkler system, in the first year or two, only a tiny bit of this water is available for the tree and these growers use evapotranspiration data to say, oh, I need 2 inches per week, and 80% of that water is outside of the reach of the tree. So it's really tricky because your roots are really just about the area of the tree. So what we really like to do is have watermark sensors. These give you a reading in tension, centibars of tension. And particular, what we found is the most useful is these lower ones. So somewhere below 1.2 or so meters, if those zones stay wet all season, you're gonna be killing trees in your orchard. This really has to dry down here over the season because you can't push all this water through the root zone without hurting the roots up in this area. So it's really essential that in fact, if you only put one watermark sensor, I would probably put it down here and just watch that one and make sure it's drying over the season. So those are just two of the brands of pressure chambers, PMS instruments. And this one's in Oregon and this one's in California. There's some other brands out there too. There's some European ones as well. I think Israel has 1 or 2 brands. So this is the conclusions for almond irrigation. Canopy growth is directly proportional to midday stem water potential unless trees are wetter than the baseline. One of the big problems we've seen recently is when growers use data from drones or airplanes, and they get this nice graph and it shows red areas that are too stressed and blue areas where it's okay. So they irrigate enough to turn those red areas blue, and then 80% of the orchard's over irrigated because it doesn't look any different usually if it's over irrigated until trees start dying. So we haven't found very much value in remotely sensed data. It just often creates more problems. I think the pressure chamber is essential. I wouldn't be a grower without them, especially during the canopy development stage where you're really trying to grow that tree as rapidly as possible. And water use and yield potential are directly related to canopy growth. And then this is just some common wisdom on why almonds need to be pruned. If you look at some of the earlier production manuals, you'll find they say you need to manage light distribution. We found that this actually creates more problems because every time you cut, you generate more growth points and it shades out even quicker, so the middle canopy dies even faster. They rejuvenate canopy to maintain productivity. We've never found this in the trials I showed earlier. Over 21 years, the less you prune, the better. Although the unpruned orchards look pretty ugly and growers don't like that, after 21 years, these orchards are not real attractive. And then decreased disease susceptibility, we haven't found that's the case, and often it's the opposite case. To manage alternate bearing, we don't have any data to support that. Manage tree size, you can do that if you cut it every year, but it's gonna come at the expense of productivity. I didn't know these have these time things in here. Summary on pruning, the less you prune during the canopy development phase, the quicker you'll come into production. We have orchards that are producing pretty yields heavy enough to harvest in the 3rd leaf. There's no data to suggest that there's a need to prune mature almond trees on an annual basis. Pruning does not sustain productivity in the short or long term. You should only prune to improve safety for workers, improve visibility of trunks. This is a big problem we have, is where you can't see the trunk, and then the shakers damage the trunk. So you really have to be able to see the trunk. Remove dead or diseased wood, improve the ability to dry nuts on the orchard floor. In conclusion, every pruning cut you make decreases yield unless it's a dead branch you cut off. And then summary on canopy light interception. The most productive orchards in our studies can produce about 5.6 metric tons per hectare. We don't recommend getting that high, but about to 4.5. And across the range of planting densities in our studies from 80 to 200 trees per acre. There doesn't appear to be any clear density-related differences in production potential. Now, we didn't have any of those super high-density orchards in that trial. I think it flips to the other direction eventually. And then keeping productivity up at this density. Oh, sorry, there's some indication that higher density plantings in our studies might be able to intercept more PAR over the course of the day for a given level of light intercept. However, keeping productivity up at this density will require breeding training work to create smaller trees, and we are beginning to work on this to create smaller trees with a little bit different, well, just basically unpruned trees that are smaller. That the harvester can fit over without having to constantly be cutting them to fit the harvester over. And this is just some sources of information. The Fruit and Nut Center has information on all orchard crops. This is our departmental website at this address. And then the Almond Board has a pretty nice publication called the Almond Almanac. The 2019 one will be out at when their conference happens in December. Right now, the 2018 one's there, but it has a lot of useful information, especially about production of varieties and all that sort of thing. And then we have a UC Davis short course every year. We alternate between almonds, pistachio, and walnut. This year is almond, November 5th through 7th in Visalia. This is a very useful course. It's 3 days in the classroom and 1 day in the field, and it covers all aspects of varieties, rootstocks, pruning, training, food safety, everything. And then Ted DeYoung has his 20 principles of fruit and nut tree growth, cropping, and management. There have been a couple of people from Georgia who I met here who have taken this class. This is kind of a general class. It's not about specific crops. It's just about how trees grow. But the people who take it really like it. I think it's a really nice course. It has 1 week in the office with a few half-day field trips, and then an additional. It's not required, but there's an additional field trip for a week if you want to do that. And then for rootstocks, I mentioned earlier, this site has some information on almond rootstocks. And that's all I had. This is an 80% orchard that we would like to, our goal. So, are there questions? Do we have time for questions? If I need my translator. English? Georgian?
You want to go first?
In English.
Oh, I know.
Dr. Lampion, thank you for this
You
presentation.
took the course.
I did.
Yeah, you can talk to him about the course.
But I have actually a question about a paper which has come out of UC Davis recently on cover crops. I haven't quite understood that there's talk about cover crops helping the almond trees, but given they are planted sort of half a meter or so away in the row meadows, I haven't quite got my head around what is the benefit of cover crop so far away from the tree?
They often help in terms of storing winter rainfall, so water infiltrates better, so you get more stored. Yeah, you often get more stored soil moisture. I don't think there's real good data supporting that so far, but there are people who claim that they get better water relations if they use a cover crop. A lot of areas in California, the cover crops are helpful because they're too wet in the spring and it helps dry the soil down. I haven't seen that paper though. I know we do have a couple big cover crop projects going on, but I'm not involved in either of them. It also helps in terms of temperature in the orchard sometimes. In fact, in pistachio, we have this pistachio salinity trial that Louise and I have both been involved in. They found that they get actually higher yields when they have a cover crop because of they think it's because of the reflection off of the dried grass. When the grass dries, that they're getting reflection up into the lower canopy and they're actually getting better production. I don't know if we have real good data to support. We have some data that indicate that. But we have looked at the light coming up off that cover crop, and there is quite a bit of that light that's reflected back up into the canopy.
In Georgia, there's a huge demand for some of the cover crops like alfalfa. So it's a great income generator for the first 2-3 years.
When we try to grow a different crop in the middle, we often have problems because you have to spray things, and so there's a lot of issues with that. In Chile, they frequently plant, like in walnut orchards, they'll plant prunes or something in the middle and then take them out, but we don't do that because of the issues with pesticides and things.
Hello. My question is about if the road direction can, if road direction can improve the light interception. For example, you said that the best goal to achieve is 80% of light interception, and in a high density there was 40%. Can you improve light interception just changing road direction? Choose the best direction of the road.
We did a big study looking at east-west versus north-south hedgerows and almond in a fairly high-density orchard, and there are big differences in the patterns of light interception over the day and the season. So we do have some real. So the active outcome of that trial was we spent a whole season doing measurements, and the day before harvest, we called the grower, and he harvested them that night without telling us. So we didn't get any yield data from that trial, but we do have some really productive orchards that have east-west hedgerows where they intercept all the light because of the sun angle. But that sometimes creates food safety problems. It's hard to drive, and that's with almonds again. So, but you could play around. I mean, we've also had some growers that have planted at an angle of about 40 degrees off of north-south, so that at the middle of the hottest part of the day, more light hits the orchard floor, and the trees don't get as stressed. So there are some things you could do, but we haven't done.
Okay, thank you.
Ik ga bilmek klar. Hello, thank you for presentation. I have a question about the food safety. Despite the salmonella, what is the most important problem associated this product during the harvesting, during the production process? Production process, what can be the most important safety issue? Yes, despite the salmonella.
Making sure, yeah, you do have to make sure. I didn't mention in detail, but that orchard where we did the mechanical hedging, when we did that, then there was no salmonella on the surface. So making sure that you have light that hits the orchard floor is helpful, because that will create a temperature that's too high for the ideal for salmonella. But once you got it really established there, it doesn't do a lot of good, because once you start harvesting, you just stir it back up. So I would say, what's most important? Making sure you don't get too heavily canopied, and make sure you don't pick up nuts when they're too wet. I don't know if the orchard that had the salmonella outbreak, we were actually harvesting that orchard 2 years later, and we had a really rainy year, and we broke. And the grower insisted we needed to harvest that day, and it was really wet, and so he still hadn't learned his lesson, in other words. And he broke 3 belts on the harvester. Each belt is $50,000. So he broke 3 belts because it was so wet it was building up with mud. So yeah, you definitely don't want to pick up wet nuts. So most growers don't sample the nuts either. The common method of deciding when they're dry enough to pick up is just snapping the hull. If it snaps, it's wet, it's dry enough. If it's flexible, it's not dry enough. But it's really helpful if you can measure the moisture content of the nuts before you start harvesting. Our bigger growers go through and sample nuts through the whole orchard in different levels of light interception, take those nuts back to the lab, and there's different methods of checking the moisture contents. Yeah.
Can you specify the question? Do we have the same aflatoxin problems in this product?
Do we have aflatoxin problems?
Yeah, we have aflatoxin problems, and those are usually related to worm damage from navel orangeworm and almond, and probably in pistachio too, right? So if you can control navel orangeworm and other pests, you minimize the aflatoxin problem. One of the other problems we have with food safety is when you're harvesting almonds, if you have 2 different varieties or 3 varieties, when you're harvesting the early variety, you'll knock some of the green nuts off the other trees. And those go into those stockpiles I showed. And you have this moist green nut in the middle of that stockpile, and you can get all sorts of mold and things growing in there. So you have to be really careful when you're harvesting. You're not picking up a lot of the other varieties that are still green. Because we have the bigger growers can stockpile those nuts. They harvested late August, and they might be stockpiled till March or April by the time they get through processing all those nuts. So they could sit there for 7 months, and there's a lot of chance for problems with humidity and things if it rains heavily over the winter. They'll often uncover those piles at night, or cover them at night and uncover them during the day, but that's a huge job. These are huge tarps. and the piles are longer than this room and 5 meters tall. I did a lot of work on stockpiles just after I started. We found that there's a lot of issues with stockpiling.
Okay. Please share your experience. How can we fill our almond garden with other species? For example, olive.
With what was it? With what?
For example, if we plant across our lines olive or other species.
Olives. Well, as I mentioned earlier, we don't do that in California because we have very strict rules about what you can spray on which crops, and if you do that, you're all often not able to spray when you need to spray for insects and things. So it creates more problems than benefits for us. Some growers plant, I think in pistachios as well as almonds or walnuts, plant some sort of beans or something in the middle when they're young, but it's hard to manage. It creates water management problems generally when you do that. And insect problems as well, yeah.
Very much for a very nice presentation. I have questions regarding of the rootstocks. Which we are looking in the Georgian condition, we have problems with the wet soil sometimes. In some area we have dry area, but we have, when we are looking on the climatical data, we have found out that we have some of the periods, it's like April, May, sometimes September, October, where we have quite rainy days. And for this moment, we have problems with the Phytophthora things, sometimes in verticilia. And what about your experience regarding of the creams rootstocks? Because we got some of information that is quite suitable for the almond. What is the experience regarding of the creams rootstocks for wet soils? Thank you.
I don't know if I haven't heard anything about how they perform in wet soils, but most of our, I think probably 90% of the plantings for the last 5 years in north of Davis in the Sacramento Valley have been on crimps, so we'll probably see that pretty soon. Most of them are still fairly young, but yeah, I don't know about how crimps is in terms of wetness. I've never heard it as being particularly bad or good. There's not a lot of data either. I mean, these growers, because so many trees blew over. There was one year where whole orchards blew over, and really, in my observation is that was related to poor water management. Actually, growers who over irrigate had very shallow roots because the neighbor would have no trees blown over. So I think there's definitely a management issue there.
უკითხები აღარ გვაქვს, მაშინ შესვენება გვაქვს ხა? გადაგმილი, შეგიძლიათ გასწრებით copyright-ზე, ცოტა გადავწყვით ჩვენს გრაფიკს. 30 დაგეგმილი შესვენება, მაგრამ ალბათ ჯობია რომ უფრო მალე შემოვიდეთ, უბრალოდ copyright-ი არის გადაწყობილი უკვე ჩვენთვის გარეთ. შეგიძლიათ გასწრებით. გელოდებით 20 წუთში უკან.